Autonomous vehicles, often known as self-driving vehicles, are all the rage in the global transportation industry. A self-driving automobile can sense its surroundings and find its way around a route without any assistance from a human. This vehicle's success depends on its ability to comprehend the route and its surroundings. Technologies including rangefinders, cameras, sonar sensors, and GPS. While some nations have yet to adopt this technology because it is still in the testing stage, the day will soon come when the mobility ecosystem will shift to an autonomous structure. A self-driving car must be familiar with the route, comprehend its surroundings, adhere to traffic laws, and behave responsibly around other vehicles and people in order to reach a specific destination. These vehicles can collect and analyze data using the following technologies to safely navigate the roads. For a clear view of the roads and traffic signals, use a camera. Radar, for spotting huge objects nearby and controlling their distance. Lidar, to more effectively detect and map 3D elements and tiny objects close to the automobile. Artificial intelligence, AI, for combining the camera and sensor capabilities of the car to make all the crucial decisions necessary to comprehend the route and the navigation. Now that you are familiar with the fundamentals of self-driving cars, let's look at some fascinating information about them. 1925 was the first step. The road to autonomous vehicles was paved more than a century ago. Francis Hodina, a former U.S. Army engineer, invented the Hodina radio control by mounting a radio control system on a car and operating it remotely. He demonstrated the usage of several functionalities while driving the car around the streets of New York, including turning, reducing speed, and honking. Due to the fact that no one was driving it, the terrified onlookers who were crossing the street dubbed the vehicle the Phantom Car. Overall, the vehicle greatly increased public interest in and enthusiasm for driverless cars. Did you know there are several levels to self-driving cars? Our perception of a self-driving automobile is binary, either it operates on its own or it does not. But automotive specialists divide this procedure into 5 fundamental stages. The system may keep warning systems on at level 0, which is sometimes known as zero automation, but all other controls are manual. Level 1 is what is referred to as driver assistance, and it provides braking or steering assistance, but not both together. This technology supports a feature called cruise control. Level 2 is partial assistance, where the system assists with steering, braking, and accelerating, but the driver maintains control. Level 3 is known as conditional automation, in which the driver occasionally allows his focus to stray from the road. With the exception of unusual circumstances like rain and snowfall, Level 4 is considered to be high automation, where the system can take over the full driving function. Degree 5 is complete automation, the highest level, when no human involvement is necessary. This system is entirely independent. Although the majority of us might not have access to self-driving car technology, the distinction between a standard car and a self-driving car is becoming more hazy. For automated functions like automatic braking, cruise control, collision avoidance, lane detection, 360-degree camera vision, etc., several operators are fitting their models with sensors, GPS, sonar, and laser technologies. Over 10 million vehicles with self-driving capabilities are anticipated to be on the road worldwide by 2020. Not just for automobiles and automobile makers. When it comes to creating self-driving technologies, the big names in the auto industry are setting the pace, but they are not the only ones. The application of these technologies to create self-driving cars and other tools is being investigated by companies like Google, Apple, Amazon, Cisco, and Microsoft, which have also rushed into this market. They are collaborating with government agencies, research centers, and the automotive industry to put money into expanding the reach of these solutions. These solutions are also being used in conjunction with other mobility options like vehicles, tractors, freight equipment, and others. Finland saw the introduction of an electric bus in 2016 without a driver or any auto systems. Self-driving vehicles rarely cause accidents. Instead, human error is at blame. Self-driving automobiles were developed to eliminate mistakes made by the driver. The majority of traffic accidents are brought on by human error rather than by direct outside or environmental variables. Customers are really concerned about the safety of driverless cars because an autonomous Uber vehicle struck a person. The first autonomous vehicle crash was caused by a human driver rear-ending another autonomous vehicle. According to data, human error has been a factor in the majority of these mishaps, which are also quite few in number overall. We can say that these cars are mostly safe to use, but further testing and research are needed before they are totally safe for the roads. Savings on insurance and taxes. As these crash expenses are covered by the money we pay in taxes, a sizable portion of taxpayer money is spent on road accident rehabilitation. As the number of incidents in a driverless ecosystem is anticipated to be far lower, self-driving cars are likely to lower these expenditures. Insurance coverage is another area where customers might save money. Since manufacturers are spending billions to address safety concerns with autonomous cars, it is expected that they would include insurance, warranty, and repair costs in the purchase or lease price. Government active investments. You are erroneous if you believe that investments in the development of autonomous vehicles are limited to technology companies and automakers. Trillions of dollars are being invested by governments all over the world in automated mobility systems and other self-driving technology. The majority of the funding for Carnegie Mellon's NavLab experiment, in which a self-driving automobile traveled from Pittsburgh to San Diego, came from the federal government of the United States. Along with this, governments are also paying attention to rules and bottlenecks that, if effectively resolved, might benefit this industry. The future of driverless technology could be Mars rover technology. In order to better manage its fleet of driverless vehicles, Nissan Motor Corp has announced plans to integrate NASA technology used for Mars rovers into driverless technology. In order to navigate around barriers, NASA used a technique called visual environment for remote virtual exploration, Verve. The similar idea underlies Nissan's seamless autonomous mobility (SAM) system. If a self-driving car becomes stuck, it may ask for assistance from a human. Consumers are showing both adoration and mistrust towards self-driving cars, but we are aware that this technology will continue to advance and will never go away. This system can eventually be improved and made available to the general public with the help of the government, technology companies, and automakers working together. Self-driving cars can help you drive better. The top manufacturer of autonomous car technology, NVIDIA Corporation, announced that their new AI-powered co-pilot system uses external cameras and radar to tell users about the surroundings of the automobile. This may contain details about people and other vehicles. The consumers can follow their movements thanks to the integrated cameras. Additionally, the co-pilot system can usually operate the automobile on its own. However, it also uses its data to demonstrate to people how to operate a standard automobile more safely. Self-driving vehicles face ethical challenges. While self-driving cars are awe-inspiring to people all around the world, they are also posing ethical and legal concerns. There are many questions, including who will be responsible for accidents or wrecks and how the vehicles can be programmed to protect the driver or take action to reduce harm to the public. It is crucial that these issues are addressed in the early stages of the development and use of autonomous vehicles. They are competent racers. It is a prevalent misconception that autonomous vehicles move slowly to maintain caution and safety. This isn't always the case, though. Consider the case of Audi. One of its RS7 Sportbacks was given technology that made it possible for the vehicle to function without a driver. This vehicle arrived at the Hockenheim Formula One track and was only 10 seconds slower than expert human drivers in the same vehicle. Additionally, it reached 150 miles per hour. Even in the dark, they can see clearly. Did you know that without the aid of headlights or street lamps, Ford's self-driving cars can see even in total darkness? According to Ford, its driverless vehicles navigated curvy, dark highways at 60 miles per hour. This is fantastic news for the automaker, which intends to introduce Level 4 autonomous vehicles by 2021 with no driver involvement. While there is both interest and skepticism surrounding self-driving cars, it is becoming more and more clear that this technology cannot be stopped. Furthermore, it will probably remain once it arrives. Governments, technology companies, and other responsible organizations are eager to make these advanced cars available to the general public. In the meantime, individuals will probably base their choice on the technological and safety advancements applicable to self-driving cars during the following few years. When all is said and done, these cars will undoubtedly propel themselves towards a promising future.